what we did yesterday in putting probability in terms of sets. So a set is simply a collection of things, numbers or objects that satisfy well-defined criteria. The things that are contained in the set are called elements. Okay, so an example of a set can be found in example 1. We have a set A. It is defined as the collection of all integers that are greater than 0 and less than 10. So this is the definition of our set. All the numbers greater than 0 and less than 10. Those are the only things that can fit in our set. And it's set A. To write this out, we're going to put a capital I equals squiggle bracket. That's what roster form means. It's using a squiggle bracket. And then we're going to write all those numbers that are greater than 0 and less than 10. You notice it doesn't say equal to 0 and equal to 10. So 0 and 10 are not going to be included in the set. It's just anything that's in between them. So what are all the numbers that are between 0 and 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10 and 0 are not included because they're only ones that are less than and greater than. Only things that are in between those numbers. There's a set A. A subset is any set whose elements are all contained within another set. So you're taking elements from one set and you're creating a new set using a new definition. So take a look at example 2. It says using the set from example 1, there is a subset B that represents all odd numbers from set A. And subset C represents all the even numbers from set A. We're going to write both of these sets in roster form. Little bracket. So B are all the odd numbers from set A. Well, look at set A. What are all the odd numbers? All the odd numbers. Okay? 1, 3, 5, 7, 9. Perfect. You're only going to... Oh, darn it. How recording?
Probably record the other one. Let's get the secondary microphone.
Set C are all the even numbers from set A. So if we look at set A, what are all the even numbers? Okay. 1, 2, 4, 6, 8. So we have set A. We can create subsets from that by taking values from set A and putting them into a new set. Or subset. Questions over that? Well, now we can take this idea of sets and subsets and apply it to what we did yesterday regarding sample space and finding probabilities. For example 3, it says consider an experiment where we first toss a coin and note the outcome, and then roll a 6-sided die and note that outcome. That's the experiment. Flipping a coin, then rolling a die, and writing down what we get. In A, it says write a set of ordered pairs that represent all outcomes in this experiment. Remember, if you're writing down every single possible outcome, you're writing down the sample space. We're going to call this sample space set S. Okay, so just like we wrote the other sets, we're going to say capital S is equal to squiggle bracket. And we write our sample space. Okay? Let's say we flip our coin. That's the first thing we're doing. What's the possible outcome when we flip a coin? What can we land on? Heads. So let's say we flip our coin. We get a heads, and then we roll our die, and we can land on a 4. Try to go in order. 1. We can land on heads and then roll a 1. We can land on heads and roll A. Land on heads and then roll A. Land on heads and roll A. 4. We can land on heads and roll A. 5. We can land on heads and roll A. Can we land on heads and then roll a 7? How wide? Yeah, it's not on the dot, so that's a possible roll. Okay? Well, those are all our possible outcomes with flipping a coin and landing on heads. Well, when you flip a coin, what's another outcome you can get? Tails. So you're pretty much rewriting the same exact thing, but with getting a tails first. You can get a tails and roll a 1. You get a tails and roll a 2. You get a tails and roll a 3. Tails and roll a 4. You get tails and roll a 5. And tails and roll a 6. Close this squiggle bracket. We suggest going in order like this because it makes everything organized and makes sure you get every possible outcome. We kind of jump around and say, oh, you get a heads and then a 6, you get a tails and then a 2, you might miss one. So try to keep it like organized and in order, that way you don't miss anything. You get all the possible outcomes. Well, how many outcomes were there? I just like to write the total, I know I'm going to use it later. How many outcomes are in this set? Oh, we have a total of 12 outcomes. I just like to write it because I know I'm going to use it later. Well, B, we're going to write a new set. It's going to be a subset of our sample space. And the definition of that subset is getting a tail and an even number. And we're going to call this set A. I'm going to say A is equal to squiggle bracket. So look back at your sample space to figure out which of those fit into that definition. Right? Well, are any of these first 6 going to work? No. Why? Because we have to. Yeah, because we get a tail. So those are all heads, so we're just going to ignore those. Tails in an even number, so that one doesn't work. Does this one work? Yeah, I'm going to circle it. Three's odd. Does this one work? Yeah, I'm going to circle it. 5's odd. Does this one work? Yeah, that one works. So I just like to go through and circle the ones that fit in that subset. Just organizes my work a little bit better. So all of those values that you circled fit into set A. Getting a tails and then a 2. Getting a tails and then a 4. Getting a tails and then a 6. They fit into that definition. For C, the complement of set A is essentially all the outcomes that don't fit into that set. So set A was getting a tails and an even number. The complement are pretty much all the leftovers. So all the ones we did not circle were the ones that did not fit in A. So that's going to be the complement. Yes, Jason.
With the with like if you were to be dealing with like a lot of sub pairs and normal pairs, wouldn't you like have to like label like A is relative has to do with S to A or something?
No, this is totally fine. How it's broken down, this is how you see it. You don't have to worry about like a certain way of writing it. If they just say, hey, it defines it right here, so by just writing A equals, you know, if you know the definition, you don't have to worry about how to write it. So this is how it will be set up for you, and this is how you just have to worry about how to write it. Good question. So again, B is the complement of A, meaning all the ones from your sample space that did not fit into A. So all the ones essentially we did not circle are A's complement. Okay? So H1, H2, all of those that we did not circle, you're going to rewrite, and that is the complement. The ones that did not fit into set A. You're going to see that word little bit right, but it helps you out by having that visual. So all the ones that you did not write in set A, go in set B. And complement is the leftovers, the one that didn't fit. Is the complement. We've seen that word a lot. Now that we have our sample space and our subsets, we're going to find the probability. So in D, we're going to find the probability first of A happening. So just like we did yesterday, the total possible outcomes always go in the bottom. So you have to go to your sample space. How many total outcomes do we have in our sample space? How many did you say? Sample space we had 12. That's going to go in the bottom. Then the amount of outcomes that fit into set A are going to go in the top. Well, how many outcomes did we have in set A? 3. That's going to go in the top. Simplify the fraction. What does 3 over 12 reduce down to? Yeah, 1/4. And then write it as a decimal. What's 1/4 as a decimal? 5. There's a 25% chance that you will flip a coin, get a tail, and then roll an even number. To find the probability of B, again, the total outcomes go in the bottom, so what's going to go in the bottom? 12. How many fit into set B? 9. What does 9 over 12 reduce down to? 3/4. And what's 3/4 as a decimal? What do you notice about these probabilities? What do they do? They equal 100, or would you add them, they equal? What's 100 as a decimal? 1. They add to 1. Okay? So a probability and its complement are always going to add to 1. Okay? Because the probability, the complement is all the leftover. So they're always going to equal 100%. They're always going to equal 1. Every time. So a shortcut to finding a probability's complement is just to take whatever you get the probability of event A happening. You could have just subtracted it from 1, and then there's the probability of B, because this is complement. Okay? We'll see that in the next example. So in example 4, the probability I will draw a red marble from a bag is 3/17. What is the probability that I won't draw a red marble from a bag? Okay? Well, whenever you see won't, will not, can't, something like those negative words, that just means complement. That just means you're finding the complement. Will not happen, won't happen, something like that. That just means complement. So if we know getting a red marble has 3 out of 17 chances, what can we subtract that from to get the complement? Yeah, there's 14 out of 17 chances, because we do 1 minus 3 out of 17. 1 minus 3 over 17, when you plug that in your calculator, make sure it's a fraction, it's just 14 out of 17. You also think, well, if there's a 3 out of 17 chance that I can get a red marble, that's kind of telling me, well, there's probably 17 marbles in total marbles. And of those 17, 3 of them are red. Well, if 3 of them are red, how many are not red? 14 are not red. So there's going to be a 14 out of a 17 chance that you won't get a red marble. Okay, you can think of it like that. There's 17 total marbles, 3 of them are red. Well, that means 14 of them are not red. So there'll be a 14 out of 17 chance. questions over that since you compliment a lot. So if it's like, what's the probability that they won't do this or will not do this? Just think, oh, I gotta take that probability that it will happen, subtract it from 1, and that will give me the probability that it won't happen. Questions? Got a few minutes to get started.